In episode 58 of Mobycast, Jon and Chris discuss the practical issues with RDS Replicas. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys, good to be back.
Yeah, so what have you been up to, Rich? We missed you last week.
Yeah, I think it might have been a couple weeks, actually. I'm not even sure the last time I've been on.
But, you still have been doing your work as a producer, so everybody listening wouldn't have heard the last few weeks if it weren't for you, so thank you.
Oh, my pleasure. Last week, my dad was in town, and so I spent the majority of my time just hanging out with him out here in Denver. So this week has been, or at least today, my dad left yesterday, has been sort of getting back on track and trying to put the pieces together.
Right on. How about you, Chris?
Yeah, I'm kind of digesting some little bit of sad news yesterday. Saw the announcement that the startup I was at before Kelsis, AirBell, abruptly just turned off the lights and shut down. So AirBell is a scientific wellness company. So the mission behind it was, instead of, our conventional medical system is all focused on treating symptoms and disease, and instead we should be focusing on having just the best health possible, right? So be more preventative, be more proactive, and really just have the most vitality that you can, and do that through science and employing things like genetic testing and blood work and microbiome and just lots of science around it and behavior change and coaching and whatnot. So they were founded in 2015 and raised a bunch of money. Lee Hood was one of the founders and he's just a legend in the medical and the biotechnology space. And so it was kind of sad to see yesterday that they just said, look, business model doesn't work, and we're just shutting it down. So
that is really too bad. I even used a couple of their services, or I tried them out, and if nothing else, I could tell that everybody there was really committed and really hardworking and wanted to see it succeed. So I'm bummed to hear that too.
There's definitely a lot of passion there. Like, you kind of need the passion to kind of like stick, because the company has had just a really hard time getting the buy-in from just the public. And I think that's a comment on just society. And it's just, we're so kind of in general, like being proactive, doing the hard work without really seeing the immediate gains is not something that we do. Instead, we just want that pill that fixes us. And I think, them shutting down, that's one of the reasons why they weren't able to make it, because they just really weren't able to find that population of customers that would do the hard work before they are faced with a diagnosis or some medical issue. Yeah.
And that's, you've known me long enough that one of my favorite metaphors when I talk to new startups is whether, are you selling vitamins or are you selling ibuprofen? And I would add to that now, or also, are you selling amphetamine?
Yes.
And the most wildly successful startups are selling amphetamine, and the ones that just struggle are selling vitamins. And that's kind of what AirBell was, is like, take your vitamins.
Yep, absolutely. So hopefully someday.
Right. Yeah. So today we're going to talk a little bit about databases and scaling, RDS in particular. And I'm excited for this because this comes straight from some really recent Kelsis experience dealing with some difficulties. So let's see, maybe you can get us started, Chris, and just kind of help us dive in.
Yeah, maybe just to set the tone a little bit, talking a little bit just about distributed systems 101. And, there's really two primary ways for scaling, right? You can either scale up or you can scale out. Scaling up is, from an architecture's design standpoint, it's definitely the simplest, right? So scale up just means, as my load increases, just buy a bigger piece of hardware, a bigger machine, a more capable machine. So I want to double my throughput, I'll get a twice as fast CPU, or I'll double the memory, right? And just continue getting a bigger machine. My software doesn't have to change. Maybe I have to change my network bandwidth or upgrade my storage, my disk space or whatnot, but don't have to change my code, right? It's pretty simple, pretty straightforward, and I can do that. But obviously there's a limitation to that. You're going to hit, you can only get so big of a machine, right? And it's going to get more and more expensive. So really, where everything has gone now, in order to deal at internet scale, you really have to scale out. And scale out is all about, now, instead of having a very expensive one server, you have a cluster of nodes, and these are more commodity hardware, and you get the power and the scalability by just having multiple nodes all being able to answer the traffic. So much more scalable. This is basically how a lot of systems do scale, but it's also a lot more complicated, right? Because now you have things like your replicating state, and how do you deal with what happens if one of those nodes is out of sync or goes down? how do you know who's kind of like the authority in there? So lots of complexity, lots of algorithms or whatnot.
Just to give a concrete example, you just use a kind of a technical term about replicating state. And I guess a concrete example would be if you've got a cluster of 100 machines and they're all answering questions, from your web session, and maybe your web session, you're in the middle of buying a plane ticket and many, parts to that. You're getting seats, you're adding luggage. Unless you do something like pin every one of your requests to a single machine that knows exactly what you're doing, what you're in the middle of, which is not a good idea anymore, but it is the way things used to work for a while. Unless you're pinning that to a single machine, then all the machines need to be able to know where you are in that process. And so that's kind of what you mean by replicating data.
Yeah, absolutely. So it's you build this cluster that from the outside it looks like one thing, but behind it it's really it's a set of different machines, but they all have to kind of be able to answer those same requests that come in. So they all need to, again, have the same data or have access to the same data, right?
They're not all having you pick your seat again.
Exactly. Yes. And so, maybe some terms to talk about here are strongly consistent versus eventually consistent. So when you're dealing with things like state and replication, you have these multiple nodes in the system. To be strongly consistent means that every single one of those nodes has the exact same set of state. So they're all very strongly consistent. So any one of those nodes at any point in time really has the exact same state as anyone else. So that from an application standpoint ends up being very beneficial, but from a practicality standpoint it's very expensive. And so this is something that not really done on a large scale, or it's just something you really have to kind of like think through and decide whether or not this is a requirement. The kind of the flip side of that is something, it's called eventually consistent. And so what this means is that, so you have that set of different machines that they're all trying to have the same state, but at any point in time, there's no guarantee that they all do have the same state. So at say T0, one of them could have like the latest up-to-date information. And then if there's two other ones, maybe they don't have it yet. But at some point, call it T1 later, they will eventually have that information. So at some later point in time, they will all be in state as of that last, right? Of course, new changes could have come in, right? So there's always this lag, this delta between them.
I'm gonna jump in again with Example Man is back. So yeah, so something that might have to be strongly consistent. I'm just thinking, when would you just need strong consistency? And one of my thoughts was like, oh, you're selling tickets to an event, and the tickets have assigned seats. If you're saying that row K, seat 3 is sold, then everybody really needs to know immediately. Like there can't be a case where some nodes think it's available and some nodes think it's sold. That's just going to break. But on the other hand, social media app, like somebody updates their status, hey, I'm having, pho in this cool restaurant in New York City. Some nodes might know about that right away, and other ones will know about it eventually, and nobody really cares that it takes a couple seconds for that to get propagated through the network.
Yeah, absolutely. So these are good terms for us to understand and have those examples and keep them back in mind, because this will play into as we kind of go through and now actually start talking about databases with AWS and in particular RDS and the various different configurations that you have there, and the fact that it's not just as simple as a checkbox to deal with this. Right.
Something that we kind of left out of the initial conversation, but it was in there, it was under the covers, and I just want to bring it up a little bit, is that, we talked about clusters and nodes. We didn't really talk about the fact that there may be, clusters of application servers that just have application code that knows business logic and is kind of stateless. And in the past, and I had kind of mentioned in the past, those application servers might not have been stateless. They might have had in-memory state that they're keeping track of. But these days, they're typically stateless. Most architects would not create stateful apps, if at all possible. So that's one cluster. And that's not really what we're talking about today. We're talking about the cluster that might represent your database. So where you're actually storing your state. So that might be SQL databases, Mongo databases, whatever. Just where is it that you're actually storing your state? And is that a single node or a multiple node cluster? And is the data in there, when you ask it a question, when you ask that cluster a question, or tell it to store some information for you, is that action, strongly consistent or eventually consistent? So just to kind of separate the two, the data layer versus the application layer.
Yeah, that's a good point. So we're absolutely talking talking about databases here. We're talking about state. Like you said, like for other things at the application layer, definitely want to make those stateless. That way you can throw a load balancer in front of them and don't have to worry about anything. Versus can't really do that with, it's not as simple, right? With database, you can't just put your RDS, you can't put Postgres in front of a load balancer. It's not going to work too well. So maybe moving on to RDS. So RDS is the relational database service with the managed relational database service offered by AWS. And so many of the popular RDS systems, such as Postgres and MySQL, SQL Server, Oracle, and whatnot, are offered. And with RDS, there's a couple options here. And it's kind of interesting because they both the kind of like the strongly consistent model as well as the eventually consistent model applies here. And so there's two main ways to kind of configure RDS from just an architecture standpoint. One is to enable multi-AZ. And what multi-AZ is you can kind of think of it as like active and backup, or primary and backup, where this is really all about dealing with availability. It doesn't have anything to do with scaling, because with multi-AZ, only one of those databases is actually available for serving request. You have that backup is being kept in sync with the primary in the case that the primary is no longer available, in which case there's a failover. And so in this particular case, you do have replication of state, and it is strongly consistent, right? This is a kind of a guarantee of the system. So when writes come into that primary, they're in real time synchronously being replicated to that backup, so that there's the guarantee that the backup is always has the same state as the primary. And you need that, right, for a failover, because it means if it wasn't, then when you did fail over, you would see basically the equivalent of data loss, which would be obviously a big problem. So that's multi-AZ option with RDS. And again, you're replicating state in a strongly consistent way, but you're paying a performance penalty for it, right? Because your writes now are a little bit longer, because it does have some weight for acknowledgement that the write to the backup happened.
Hey there, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 30,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes to leave us a review. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
The other main way of configuring these RDS would be to enable read replicas. And so with read replicas, you are creating, again, multiple servers for your database. It is replicating the state, but this replication is happening asynchronously. And so you're not guaranteeing that when that write happens that it gets propagated to all your read replicas at the same time. Instead, it's being done in the background, and there's some replication lag, and basically it's adhering to that eventually consistent model. So but what this is good for is that you can actually now use those read replicas to serve up your read operations. So read replicas is definitely something that you use to increase the scalability of your system, especially if you're a read-heavy application. Read replicas aren't going to help you if most of your operations are writes, but fortunately, most applications out there, they are much more read-intensive than they are writes. And so you can enable read replicas in order to increase the scalability of your application.
Right. So you're a startup and you've got an application out there and it's got pretty low traffic most of the time. And it's been just living on a single, you've got multi-AZ configured just because availability is important to you. But it's been living on just, one instance, one medium-sized instance on RDS. And holy shit, all of a sudden you've got a viral thing happening and you've got thousands of people signing on, and you're looking at your database load and you're like, oh my God, this database is not going to be able to handle this. We don't want to turn users away or look like we're having a bad time. So let's do it. Let's just flip on a read replica, right?
Absolutely. Yeah. I mean, this is like, AWS 101, right? Like you'll just do a Google search or look at the documentation, right? It's like, hey, if you need more scalability with your read operations with RDS, go use replicas, enable read replicas. And it's something in the console. It's super easy to, it's like a checkbox, right? It's really easy to enable read replicas for a database. And so it's kind of interesting that it's glossed over, right? Like that's not all the work, right? Like this actually has pretty big ramifications on your architecture and on your application in order to consume this. And so there's, you do have to roll up your sleeves and do some heavy lifting here in order to take advantage of this new architecture. It's pretty, if you think about it, I mean, definitely it's pretty sophisticated. You're going from a single node to a multi-node stateful environment. There's that replication going on. And how do you now load balance your request across these things? So these are all things that you have to consider now once you've made that choice.
Right, Chris. So I just have to say something real quick. And before I do, I just want any potential clients of Kelsys to just go ahead and turn off the podcast right now. Just turn it off. Okay, now that they're gone, I will say that there was a team at Kelsys that recently made this mistake and they just flipped on the checkbox. And yeah, guess what happened? Maybe Chris can tell us.
Yeah, so I'm always kind of blown away by the fact that like it just from the documentation, everything that you see, and people will, solution architects and whatnot will just say, okay, just enable read replicas and away you go. But it's not that simple. So some things that now happen is that your read replicas actually have different endpoints. They're basically different DNS entries than your primary. So if you don't change anything in your code, like it's still going to be going against your primary, even though you enabled your read replica. So you now have to change your code.
Right. And so they did, right? So they just made a quick hot patch, pointed the read operations at the read replica, done, right? It works.
Mm-hmm. Yeah, absolutely. And if you've somehow magically made it so that your application is only doing read operations on those, then that's fine. But if you send a write operation to a replica, it's not going to go so well. The replica will fail it, right? You'll actually you will get denied, right? Because it's a replica, it's a read replica, so it's read only. So
and that's exactly what happened to us. And this may be a language thing. It could be that we were using this particular library with JavaScript called Sequelize. Maybe many of you listening are using that, and I guess apparently it's possible to kind of label the queries in Sequelize. I haven't actually used it myself, but you label them for what they are. This is an insert, or this is a write, or this is a query. And I guess Sequelize doesn't really care if you mislabel them. It doesn't do anything about it. If you have a single database and you call something a query that actually has an update in it, it doesn't say, hey, you can't do that. But the read replica will. The read replica will say, hey, you can't do that if you try to send an update to it. And Sequelize knows which database, whether to use the read replica or use the main database based on how those queries are labeled. So it's really important to get them exactly right.
Absolutely. Yeah. So this is, it is one of the things where once you do enable read replicas and you have considered your application and, most libraries out there that you're using as middleware to go and do data modeling and talk to a database, they understand the difference between read versus write. It's just for this exact kind of scenario, but it's not like they can analyze the exact operation that you're sending and always know that this should be sent to the reads or this should be sent to the writes, right? So there may be some of the basic straightforward kind of syntactic sugar operations that it knows, like, oh, if you're doing a create or an insert, like, then this definitely should go to the write, to the master, to the primary. But if you have some arbitrary SQL, maybe some complicated SQL that you want to go, it's going across multiple tables, doing some joins, and maybe it's doing some other kind of advanced stuff. So you have kind of more of a hand-rolled SQL statement. It's not going to know how to label that necessarily. So you really do have to kind of think this through and look at this. And it really, once you do make this change to go to read replicas, the onus is on you to really make sure that you've done that coverage, that you've gone through the code, and everywhere you are making these kinds of database operations, have they been identified, flagged accordingly? Otherwise, you're going to get a really rude awakening when you go to production, and it's like, maybe that one operation that is very rarely executed that you forgot, that you didn't catch, it's going to, start failing at, midnight on a Saturday night. And it's because that actually is a mutable operation. It should have gone to the primary, but instead you sent it to the replica and the replica just failed it. So now it's going to continue to fail, right? Like your code's not going to do anything different. So you're basically now just completely failed for that.
Just to add some color to this, I do feel like this may be, a classically startup type problem. It's the type of problem that happens when you're trying to not overbuild things in the beginning, and then later you're trying to add some capacity. And it's maybe less of a problem when you're building for scale from the start, because day one is going to already have tens or hundreds of thousands of users and going to need, a cluster to begin with. So many of us get our experience through these startup type situations. So good to know about.
Yeah. And it's not even just like startup companies, right? It's just at the beginning of a project, like you don't need, read replicas necessarily, right? Like the traffic's not there. So it's, even if you're in an enterprise or doing it, in a big company, like you probably still go through this same kind of life cycle. You won't be doing it from the get-go. The other thing, another big gotcha with replicas is, we talked about strongly consistent versus eventually consistent. And these read replicas, they are eventually consistent. So, normally your application code, when it's making calls to the database, making operations to the database, it's kind of operating against a strongly consistent data model. So you go and write something to the database and then you read it back, you expect it to be there. When you go to this multi-node system with read replicas, that's not the case anymore. So if you write to the primary and then immediately try to read that data back from one of the replicas, it may not be there yet, right? Because it still has to replicate. And so this has really pretty severe consequences to your application. Like you have to be thinking through, like where is my code expecting the strongly consistent model? And when that's the case, like I can't read from the replicas. I have to be going against my primary. So really the traffic going to the read replicas should be the read operations that can handle the eventually consistent model.
Right. And just since it's just us, again, since all the potential clients left, another story that I have to tell you is that, yes, Kelsis also, after fixing the issue with labeling queries and having read replicas work in production for several weeks in a row, we got bit again. And it was like, how to get it again? And it turned out that it was exactly this eventual consistency thing. Somebody wrote some code that expected to be able to, go through a sequence of 5 or 6 database operations that were not part of a single transaction. And in in the second operation, they were maybe reading from some stuff they inserted into a table in the first operation. And, our staging environment was not the same as our production environment. And so in staging, everything just worked beautifully. And then suddenly when we put it into production and, the business was just depending on it working absolutely right, it totally broke because of this eventual consistency problem. So I think the lesson learned there is not just knowing about eventual consistency and planning for it, but also, not taking shortcuts with your staging environment, even if it is going to cost you extra to have a full production, copy in your staging environment.
Absolutely. So, again, I think the big takeaways here is that like things like read replicas, having clusters of state, very important for scaling. You're going to have to do it. But even with all the help that you have out there and these managed systems, it's not as simple as checking something off in a console and enabling it. You really have to understand, like, what does this mean to my architecture? What needs to change in my software? How do I test this? How do I verify that this is working the way that I expect it to? So it's not easy work.
I would say that when you run into a problem that's caused by eventual consistency, it's going to be a big problem because you just can't do a quick hot patch. Like, oh my God, the data is really getting messed up, and where exactly is this SQL that's depending on something that just got inserted? Like that's not a quick one-liner change usually. So planning in advance is going to save you some real headaches with your users.
And not only that, usually like this is like it ends up being kind of like has the feeling of like spooky logic, right? Or it's fuzzy, right? So it's not when you do have this problem, it's not like you're failing necessarily. It's just that maybe it's just like again like data that you expected to be there isn't there, and so that has like some ramifications, and you're gonna get it's just like the wrong result. But like you may not be able to detect that very quickly, right? Or it may take some time before you start hearing complaints from your users saying, "Why do you think a lizard is cuter than this kitten?" Right? Like why did the lizards beat them in the rankings? Like that doesn't make any sense. And it's like, oh well, you know what? The kitten votes, they're still replicating.
Exactly. All right. Well, I think that's a wrap. Thank you for talking through such an important part of database architecture.
Yeah, this was fun. Thanks, guys.
Thanks, Chris. Thanks, Rich. Talk to you next.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/58. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.